I'm Dave Duguid. I'm a lab instructor in electronic systems engineering at the University of Regina. Prior to coming here, I worked in the datacom industry for a number of years. At the U of R, I'm responsible for labs in communications, microelectronics, and in concert with Keegan Downey, I teach some very early labs in electronic circuits.
Hey everybody, I'm Keegan Downey. I'm one of the lab instructors at the electronics program here at the University of Regina. I specialize sort of in the areas of power, as you can see behind me, and controls. In my previous life, before I came to teach here, well, first of all, I'm a graduate of the program. I graduated in 2006, and I went out and I worked locally here in the city and throughout the province. So during that time, I worked for local consulting companies in sort of designing electrical systems for buildings, and I also worked at SaskPower doing capital projects, and as part of my work there, I got to do some commissioning at the Boundary Dam Clean Coal project. So those are some of the highlights from my career outside of university. And like I said here, I am a lab instructor in the electronics program, and I specialize in controls and automation and power and distribution, just based on my experiences out in industry. Yeah.
Automation and controls is about building controllers for industrial processes, robotics, pretty much anything that requires a computer to control an operation. We use industry standard software in order to configure the systems to create solutions for problems that users have. And we download those solutions into controllers and let them work. Power protection and control ensures the power grid stays stable. Understanding how to deliver power efficiently to industrial equipment is part of our power program. Equally important is understanding how to interface with other members of the engineering team. Communication systems involve everything from networking to radio systems to antenna design. And understanding the proper configuration and operation of test equipment is critical to knowing what the communication system is doing. Communication systems are modeled using different pieces of equipment, and in later classes, entire computer networks are constructed using industry standard equipment. Microelectronics is the glue that ties everything together. We use computer tools to design new hardware or new computer programs. We use simulators on the computer to ensure that everything is going to work as expected before we deploy it to the field. Once testing is completed, we implement our design and send it out for customers to use. Everybody gets the same start. Learn how to configure the test equipment, how to build the circuits, how to take the measurements so you can understand what's going on inside the integrated circuits. Just because there's a pandemic doesn't mean we're not going to have classes. Lab kits go out to the students so they can learn remotely. It's about getting your hands on the equipment, designing circuits, and putting them together yourself. A large percentage of your coursework will be project design and implementation. Here we see a third-year project. It's based on a Raspberry Pi, an ARM microcontroller, some custom 3D printed parts, and an off-the-shelf Connect 4 game. The Electronic Systems Engineering program at the University of Regina opens the door to many interesting and exciting careers.